What do you mean by vernier caliper, beta? Anyone? What is a vernier caliper? A device which is used to measure the minimum reading, isn't it? So in this one, the first term, what you need to remember for doing the examination questions is least count. Least count represented by LC. Okay. How do you define the least count? Least count is nothing but what? It is the minimum. It is the minimum reading. It is the minimum reading that can be measured. That can be measured from instrument. That can be measured from your instrument. Is called what? Least count. I hope everyone got it. What do you mean by least count? It is the minimum reading that can be measured from this instrument. Is called as of your least count. Is called as of your least count. Am I clear, beta? Sure. See, the least count generally has two main parts, beta, in this one. So if I'm talking about the two main parts for the given condition, the first one is main scale. So this one is your main scale. Okay. See the readings of this one. Starting from here, somewhere here for understanding, I'm taking it as 0, 1, 2, 3, 4. This is 5. Then 1, 2, 3, 4, and this is 5. So this will be equal to up to here 1 centimeter. 0 to 1 centimeter. And below there is one more reading, beta. There is one more scale that we are calling it as of your vernier scale. I'll write the names, don't bother. Down is right now for me one more scale that will be equal to what for me? Vernier scale. Readings of this one you see right now here. This one is having a reading of 0. This one is right now 1. This is 2. This is 3. This is 4. This is 5, 6, 7, 8. This is 9. And this one is right now for me 10. Right now, this one is your 10. The above scale is known as what, beta? Main scale. This one is called as what for me? Main scale. And below one is called as of your vernier scale. This is called as what for me? Vernier scale. Okay. Now see, beta, in above one, how many divisions are there? 0 to 1 centimeter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally 10 divisions. Let's see, 0 to 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is 10. That means I can say that in 1 centimeter, we are having how many divisions, beta? 10 divisions. We are having your 10 divisions of which scale? Main scale. 10 divisions of your main scale. So 1 centimeter is equals to how much for me? 10 divisions of your main scale. Now can you tell me 1 centimeter is equals to, can I write like this? 1 centimeter is equals to 10 main scale division, MSD. Okay. So therefore, can I say that 1 MSD is equals to 1 MSD is equals to 1 by 10 centimeter, beta? This will come here right now. 1 by 10 centimeter. 1 by 10 is nothing but how much for me? 0.1 centimeter. 0.1 centimeter. 1 centimeter will be equal to how much for me? 1 mm. Am I clear? Am I clear? So what is the condition? 1 MSD is equals to 1 by 10 centimeter, or that is equals to 0.1 centimeter, or that is equals to 1 mm. Am I clear with everyone? Am I clear? 1 main scale division is equals to 1 by 10 centimeter or 0.1 centimeter or 1 mm. So comes again, what is a vernier caliper? In that one, the first term what you are learning is least count. Least count is nothing but what, beta? It is the minimum reading. It is the minimum reading that can be measured from an instrument. It has two scales. Above one is known as main scale, which is not movable. Now down one is known as vernier scale, which is movable. Okay. Above one, 0 to 1 centimeter, how many divisions are there? 10 divisions. That is the reason what I have written. 1 centimeter is equals to 10 divisions of main scale. Therefore, 1 centimeter is equals to how many divisions beta? 10 main scale divisions. So therefore, 1 main scale division is equals to 1 by 10 centimeter or 0.1 centimeter, or that will be equal to 1 mm. Am I clear up to this one? So therefore, now how do we calculate the least count? Least count calculate करने का formula. So if I am talking about the least count is equals to 1 main scale division minus 1 Vernier scale division. This is the formula for the least count. Least count is equals to 1 MSD minus 1 VSD. Least count is equals to how much for me? 1 MSD minus of your 1 VSD. Am I clear? So least count is equals to 1 main scale division minus 1 Vernier scale division. MSD means main scale division. VSD means Vernier scale division. And how do you calculate that one? I'll write here. It will be comfortable for you. MSD is nothing but length of main scale division. Length of your main scale division. And VSD means what right now for me? Vernier scale. So it is your length of Vernier scale. It is your Vernier scale division. Am I clear? That means what better? From here to here, if you see it very carefully, 0 to 1, this distance is there right now. 0 to 1. This distance is nothing but equal to 1 mm. Am I clear? 0 to 1 or 1 to 2, this distance is known as equal to 1 mm. So in the main scale, from 0 to 1 centimeter, we are having how many divisions better totally? 10 divisions. That is the reason I am taking about right now. 1 centimeter is equals to 10 main scale divisions, and 1 main scale reading is equals to 1 by 10 centimeter or 0.1 centimeter or 1 mm. Therefore, least count will be equal to how much for me? 1 MSD minus of your 1 VSD. Am I clear with everyone? Okay, sure. Now let us try to talk about Vernier scale. Idea of Vernier scale. How do you calculate the Vernier scale? Okay. Now see beta, in the above diagram, 0 to 10 divisions are coinciding with this 10 of the Vernier scale is coinciding with the 9 of the main scale. Are you able to see it? Are you able to see it?
Yes,
Isn't
sir.
it? 10 Vernier scale divisions is matching with your 9 main scale divisions. That means I can say right now here 1 MSD will be equal to how much for me? 1 MSD is equals to 1 main scale division is equals to, we know the answer, 0.1 centimeter. Now what I am interested, VSD. So can I say that 9 main scale division is coinciding with 10 Vernier scale divisions? See the diagram. 10 Vernier scale divisions are coinciding with your 9. So can I say that 9 main scale divisions is equals to your 10 Vernier scale division. Therefore, 1 Vernier scale division will be equal to 9 by 10 main scale division. So this is your 1 Vernier scale division. 1 Vernier scale division is equals to 9 by 10 main scale division. Am I clear? So can anyone calculate me now the least count? Therefore, least count is equals to, what is the formula? 1 MSD minus 1 VSD. That is equals to 1 MSD minus 1 VSD is how much beta? 9 by 10 MSD. Isn't it? MSD I can take common right now here. So this value will become how much for me? 1 minus 9 by 10 main scale division. Now take the LCM right now for this one. Total LCM is right now 10. So this value will be here how much for me? 10 minus 9 into your MSD. Isn't it? Now 10 minus 9 is how much better? 10 minus 9 is nothing but equal to your 1 divided by 10 ms into your D. So therefore, can I say that least count is equals to 1 by 10 into main scale division. 1 main scale division is equals to how much for me? 0.1 centimeter. That means I can write here least count will be equal to 0.01 centimeter. This will be the answer for this one. Am I clear? Am I clear? Very good. Once again. So what I'm talking about right now, Vernier scale. Now Vernier scale is nothing but which one beta? The down one, and which is movable. One more thing you need to remember, Vernier scale is movable. Main scale is not movable. It is fixed. It is not movable. That means it is your fixed. You can't move it. The down one is right now for me movable. Now see the diagram. 0 to 10. 10 of the Vernier scale is coinciding with 9 of the main scale division. That is the reason what I have written here. 9 main scale divisions is equals to 10 Vernier scale division. Therefore, 1 Vernier scale division will be 9 by 10 MSD. Therefore, I can calculate the least count by using the formula. Least count is equals to 1 MSD minus of your 1 VSD. 1 VSD is 9 by 10. So it is 1 minus 9 by 10 MSD. You know the value of MSD? MSD is equals to your 0.1 centimeter. So least count will be equal to how much beta? 0.01 centimeter. Am I clear? Am I clear? Shall I do one problem based on this one? Sure. See this question beta, everyone. Now say if in a Vernier scale or in a Vernier caliper, n main scale division MSD is equals to n plus 1 Vernier scale divisions. Got it? And length of main scale, length of your main scale, length of the main scale division, length of your main scale division is 1 mm beta here. Make sure of your units. It is 1 mm. Now then question is, then find its least count. Then find its least count. Then find its least count. चलो try again. चलो. If in a Vernier scale, how many beta? N main scale division. So right now in the given problem for me, it is given in the problem that N main scale division is equals to N plus 1 Vernier scale division. Therefore, 1 Vernier scale division will be equal to how much beta? 1 VSD is equals to N divided by N plus 1 main scale division. This will be 1 VSD. Now it's asking us to calculate the least count. So therefore, least count will be equal to 1 main scale division minus 1 Vernier scale division. That is equals to 1 main scale division minus 1 Vernier scale division is how much beta? N divided by N plus 1 main scale division. Am I clear? Now if I take MSD common right now for this one, this value will be equal to how much beta? 1 minus, this is your N divided by N plus 1. This will be equal to your main scale division. Now do the calculation. So if I take this one here right now, this value will be equal to, LCM for this one is totally here N plus 1. So obviously here it should be equal to how much for me beta? N plus 1. Isn't it? Minus this value is right now for me N. Isn't it? So this will be your MSD. This is your MSD. Now tell me, is anything is getting cancelled here right now? Anyone? This plus n minus n will get cancelled. So the answer will come out for me how much better? This value will be equal to 1 divided by n plus 1 main scale division. Isn't it? So that means that value will be equal to how much better? 1 divided by n plus 1 into 1 main scale division is how much better? 1 main scale division is given how much for me the problem you see? 1 main scale division is given as of your division of main scale division is 1 mm. So 1 mm is right now for me 1 by n plus 1. This will be the answer for me in mm. Okay, MSD is equals to 1. So this will be equal to your mm will be the answer. Now can anyone tell me the answer in centimeters? If I need the answer in centimeters, 1 mm is 1 by 10. That means this value will become for me 1 by 10 into here it is n plus 1 centimeter. This will be the answer. Clear? This is the answer. I'll write it once again. So what will be the answer for this one? This will be 1 divided by 10. 1 mm is equals to into your n plus 1. Unit will become for me centimeter. You need to check with the options whether it is in mm or whether it is in centimeters. Am I clear? Am I clear? So I hope you got an idea how to do the least count problems. Clear everyone? Shall I tell you once again?
Please once repeat, sir.
Okay, fine. See this one better. If in a vernier calipers is given in the problem, that is n main scale divisions are coinciding with your n plus 1 vernier scale divisions, and is telling in the problem that length of the main scale division is 1 mm. Okay, and find the least count. Given in the problem is n main scale divisions is equals to n plus 1 vernier scale division. This is given for me. So therefore, from this one I am getting one vernier scale division is how much? One vernier scale division will be equal to n. This n plus 1 will go down, n plus 1 into main scale division. Now what is the formula for the least count? Least count is equals to 1 main scale division minus 1 vernier scale division. Am I clear? Am I clear? Then that is equals to 1 main scale division. 1 VSD value is this one. This value I am substituting here. So it is n divided by n plus 1 main scale division. MSD is common. So it is 1 minus n divided by n plus 1 MSD. Now take the LCM of this one. N plus 1. Here it is n plus 1 minus n. This is plus n. This is minus n. It will get cancelled. So the answer will be equal to how much for me? 1 by n plus 1 MSD. Given in the problem, given 1 MSD is equals to 1 MSD is equals to 1 mm. That is the reason I have written here 1 MSD is equals to 1 MSD is equals to 1 mm. Now this is the answer in mm. If he is asking the answer in centimeters, 1 mm will be equal to how much better? 1 mm is equals to 1 by 10 centimeters. This is 1 by 10 centimeters. So 1 mm I have written as 1 by 10 centimeters. This will be the answer for this. Am I clear? Am I clear? Shall I do one more problem based on this one? Sure. See this question. A vernier caliper, try to do it everyone better. A vernier caliper has 1 mm mark. Try to understand the question terminology, very important. 1 mm marks on the main scale. On the main scale. Okay. Stop. It has 20 equal divisions. It has your how many? 20 equal divisions on the vernier scale. On the vernier scale. Then which matches with 16 main scale divisions. 16 main scale divisions. Okay. Find least count. Find least count. Read the question once again. A vernier caliper has how many mark beta? 1 mm mark on the main scale. That means what? That means what? 1 mm mark. This diagram. This is the main scale. No? The distance between these two. This one. This one is equals to how much for me? 1 mm is telling. Like 7 to 8 distance or 8 to 9 distance or 6 to 7 distance. This distance is given as of your how much for me? 1 mm. Now read the question. A vernier caliper has 1 mm mark on the main scale and it has 20 equal divisions on the vernier scale, which is matching with your 16 main scale division. Okay, I'll just let me write the data. What is given in the problem for me is that 1 main scale division is equals to how much for me? 1 mm mark. Units are very important, isn't it? And still, what is given in the problem? 20 VSD, vernier scale division. See here, 20 equal vernier scale division is matching with your 16 main scale division. Okay. Therefore, one vernier scale will be equal to how much better? 1 VSD will be equal to 16 divided by 20 main scale division. Am I clear? This is given in the problem. Given in the problem is 20 equal divisions on the vernier scale is being matching with your 16 main scale division. That's what I have written here. 20 VSD is equals to 16 MSD. Therefore, 1 VSD is equals to 16 by 20 MSD. Am I clear? Am I clear? Now, how do you calculate the least count? So, just write the formula. Least count is equals to 1 MSD minus 1 VSD. That is equals to this one is your 1 MSD minus 1 VSD is how much better? I got here right now 1 VSD. 1 VSD is equals to 16 by 20. 1 VSD is equals to 16 by, very good. So this value if I am writing here, so this one is 16 divided by 20 MSD. Am I clear? So now do the LCM for this one. So this is right now for me 1 minus 16 divided by 20 MSD. Am I clear? So if I take the LCM here right now 20, this value will be equal to 20 minus of 16. This will be equal to MSD. 20 minus 16, that will be equal to how much for me better? 4. 4 divided by 20. This is your main scale division. Am I clear? Therefore, I can write least count is equals to 4 divided by 20 into 1 MSD is equals to how much better? 1 mm. Am I clear? Am I clear? 4 by 20 means what I can write here better? This value will be equal to right now 2 2s are 2 10s are. Isn't it? So that will be equal to how much? 2 mm divided by 10. That means this value will be equal to 0.2 mm. That will be equal to 0.02 centimeters. That will be the answer. Am I clear? Am I clear? Very good.
Okay.
Mr. Shafi has given me the answer. Least count will be 0.02 centimeters or 0.2 mm. Am I clear? So this is the basic thing of your least count of the vernier. How do you do it outright? I hope everyone got an idea about your main scale division vernier. So if I represent the diagram better, let me check with your diagram if I'm having it. I'll check it out here. Yeah. 5, very good. 1 by 5. So I hope everyone got an idea how to calculate the what do you call that one, least count. Shall we go for the next topic? Sure. Next one is how to take the reading of vernier scale. Excited in flow. How to take reading. How to take the reading of a vernier. Of a vernier caliper. Got it? किसी को फॉर्मूला याद है? See, these are the revision classes. Okay. Chalo. Anyone remember the formula? Let me write the formula for you. Reading is always taken as reading of the vernier caliper or reading of the vernier caliper is always equals to MSR plus VSR multiplied by least count. This is your reading. Reading is equals to MSR plus of your VSR multiplied by your least count. Am I clear? What do you mean by LC? I'll write here. LC is nothing but what for me? Least count. Terminology समझना बहुत ज़्यादा important है बेटा. Now what do you mean by MSR? MSR is nothing but main scale reading. This one is your main scale reading. Main scale reading, how you will take, that is very important. In the bracket you can write here down. I'll write with the other pen. It will be easy for you to remember. Okay. What do you mean by main scale reading here, MSR? Reading of main scale. Make it a little bit wider. Okay. Reading of a main scale to the left side of 0 of Vernier scale. 0 of Vernier scale. How do you take it? Everyone? I'll tell you better. Isn't it? What do you mean by MSR? MSR is nothing but main scale reading. And how do you read that one? How do you take that one? Reading on the main scale to the left of your 0 of Vernier scale. इसका मतलब क्या हुआ? Anyone? I'll roughly explain here. You see, this is your main scale beta, and here there is a reading of 5, and here down there is a Vernier scale, isn't it? This is your 5, isn't it? And this is your Vernier scale. Now this is 0 of the Vernier scale. Before the 0 of the Vernier scale, what is the reading of the main scale? You're able to see 5. That means main scale reading will be 5. That's what it means. Reading of the main scale to the left side of 0. Left side of 0 के पहले जो भी reading दिखाई देगा main scale पे, that will be the reading of your main scale part. Am I clear? Chalo. Next one. What do you mean by VSR? VSR is nothing but what for me? Vernier scale reading. Vernier scale reading. Vernier scale reading. Vernier scale में reading मतलब यहाँ पर number of divisions. It is nothing but what? Number of divisions of your Vernier scale. Vernier scale that coincide with any division with any division of main scale, with any division of your main scale. So what do you mean by VSR? Vernier scale reading, the number of divisions of Vernier scale that are coinciding with any division on the main scale. Roughly बता रहा हूँ, देखो ये हो गया आपका main scale. This one is 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. मान के चलो this one is 9. Okay, and down there is a Vernier caliper right now here like this, and here this one is right now for me 0 of 0. Then this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is your 8, and this is your 9. You see, 9 is coinciding with this one. So 9 of the Vernier scale is coinciding with 8, with any number on the main scale. See here, number of divisions of Vernier scale that coincide with any division. It may be any division of main scale, but it should coincide. Where it is coinciding? 9 is been coinciding with some reading of the main scale. Now Vernier scale reading will be VSR will be equal to 9. Am I clear? Am I clear? Am I clear?
Yes, sir.
Isn't it? Look, let me do one problem for this one. You'll get a rough idea related. Now try to remember the formula. Reading is nothing but equal to how much for me? Reading is equals to main scale reading plus Vernier scale reading multiplied by least count. So you got a terminology idea of all of them. What do you mean by least count? Least count, LC is your least count. MSR is main scale reading, a reading of the main scale to the left side of the 0 of Vernier scale. Then what is VSR? Vernier scale reading, that is number of divisions of Vernier scale that coincides with any division of your main scale. Let me explain you with one problem. You'll get an idea and tell me the answer for this one. I'm roughly drawing the diagram, so don't try to take it granted. Now this one is your main scale. Okay, this one is right now for me what? This one is your main scale. Okay, now if I'm taking the readings of this one, here is somewhere here. This one is right now for me 0 for your understanding. This one is 0. Okay, then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and this one is right now for me 1, 2, 3. This one is 1, isn't it? Now somewhere here down there is a Vernier caliper. Now here there is somewhere here right now for me, somewhere here right now I'm having a Vernier caliper down of this one, somewhere here right now. Okay. Now see here, if I am taking this reading right now for this one, so this one is 1, 2, 3, isn't it? So now say somewhere here right now for me, this one is right now for me here 0. Then this is 1, 2, 3, 4, this is 5. 1, 2, 3, 4, and this one is right now for me 5. Okay. Now this one is 0, isn't it? So if I'm writing this one, 1, 2, this one is 3, isn't it? This one is 5, this one is 6, 7, 8, 9, and this one is right now for me 10. Now above one you see right now for me here, this one is 1, this one is 0, 0 of Vernier scale. Okay, these are 1, 2, 3, the numbers below that one right now for me. Am I clear? The reading somewhere here right now. This is somewhere here. This one. This one is like say 2 centimeters. Am I clear? Now tell me anyone, what is the reading of this one? What is the reading of this one? I have given you the problem. Given least count is equals to 0.01 centimeters. This is given. I need the reading. Anyone? Reading is equals to, carefully, reading is equals to MSR plus VSR multiplied by least count. What do you mean by MSR, beta? See here. What do you mean by MSR? Anyone? What do you mean by MSR? MSR is nothing but reading of main scale to the left side of the zero of Vernier. यानी वर्नियर स्केल के 0 से पहले जो भी रीडिंग आपको दिखाई दे रही है मेन स्केल पे, कितनी रीडिंग दिखाई दे रही है? एनीवन? 1 दिखाई दे रहा है, 2, this is 1 right now for me, isn't it? So what is the number I am able to see? 1, this is 1, 2, 3, 1.3, isn't it? So main scale reading will be equal to how much for me? 1.3 centimeters. देखो this one is visible. After that, how many 0 से पहले कितने divisions दिखाई दे रहे हैं? 1, 2, 3. So that is the reason 1.3 plus. What do you mean by Vernier scale division? Anyone? Vernier scale division means number of divisions of Vernier scale that are being coinciding with any division of main scale. Now see, any division of the main scale पे कौन सा coincide हो रहा देखिए यहाँ पर 7 is been coinciding. This one 7 is been coinciding. Am I clear? Am I clear? 7 is been coinciding. That means it will be equal to your 7 multiplied by least count is 0.01 centimeter. That is given for me in the problem. Am I clear? See here, 6, 7. This 7th one is coinciding with 2 centimeters. Any, whatever may be the reading of main scale, that is immaterial for us. But which number is coinciding of the Vernier scale? This is your Vernier scale. This is your main scale. 7 of the Vernier scale is coinciding with 2. Some number is coinciding. So that number is 7 right now for me. So the answer for this one will be coming out right now for me. 1.3 centimeter plus 7 into 0.01 will be 0.07 centimeters. So the answer will come out for me how much for this one? This is 1.37 centimeters. Am I clear? Very good. Am I clear?
sir.
Isn't? फिर एक बार बोलो, समझ में आया?
Sir, once explain MSR reading.
MSR reading you see right now, beta. MSR reading before 0 of Vernier, how many readings you are able to see? This is 1. After that, how many readings? This 1, 2, 3. So it is 1.3. Am I clear?
Okay, sir.
Isn't
Yes.
it? 0 before 0 of Vernier scale, whatever the readings of main scale it is visible for you, that value you need to write here. And VSR means the number of the VSR which is coinciding with the main scale. So 7 is coinciding with your some number on main scale. So that coinciding number is 7. Least count is given as 0.01. So 0.01. So it is 1.3 plus 0.07. So this will be 1.37 centimeters. Am I clear? Am I clear? See, let me tell you all of you, I am trying to do only those topics by which we can at least minimally do 20 to 25 questions. My first priority is to do the 20 questions in the NEET 2025. That means by default, you need to do at any cost 80 marks, you need to get it out. And for that one of the very important and scoring topic is units and dimensions, errors, and instruments. In the instruments also, we have very two good instruments, that is Vernier scale and screw gauge. And students don't have much grip on this the topic. That is the reason I'm doing detailedly Vernier scale and screw gauge also. I'll do it detailedly. You practice it. I'll send the notes also for you. You practice the notes from this one and try to do some numericals of the PYQs related to this topic from the previous years. So you'll get an idea how the questions have been framed on the Vernier scale and as well as of your screw gauge. Am I clear, beta? Am I clear?
Yes, sir.
Yes, sir. Yes, sir.
I'm giving you a question. Try to do it out, beta. Write the question with me. The smallest division on main scale. The smallest division on main scale of a Vernier scale is 1 mm. 1 mm and 10 Vernier scale division coincide with 9 main scale division. 9 main scale division. The only problem with this topic is this, ki the question appears to be very lengthy, but literally the answer will be in one line. Okay. The smallest division on the main scale of the Vernier scale is 1 mm and 10 Vernier scale divisions of your coincides with your 9 main scale divisions. First of all, while measuring the length of the line, the zero mark of Vernier scale lies between 10.2 centimeter and 10.3 centimeter, and third division of Vernier scale coincide with a main scale. Okay, with a main scale division. This is a question. Now in this one, two parts of the questions are there. One is determine the least count of calipers. Okay, and second question is length of the line. What do you mean by the length of the line? Anyone? क्या पूछना चाह रहा आप? Can anyone tell me? Length of the line means he is indirectly asking you reading. Okay, now read the question, everyone. First, be careful about reading the question. That's very important for me. The smallest division of the main scale of a Vernier scale is how much for me? 1 mm. 1 mm. And 10 Vernier scale divisions are coinciding with your main scale division. So let me write first the data given for me. Writing the answer for this one here. Okay, now given 1 MSD is equals to 1 main scale division is equals to given as 1 mm. Okay, therefore, now what is telling in the next part you see right now? Is telling that 10 Vernier scale divisions are coinciding with 9 main scale divisions. So can I say here 10 Vernier scale divisions are coinciding with 9 main scale divisions, isn't it? So therefore 1 VSD will be equal to how much, beta? 1 VSD is equals to 9 by 10 MSD. First question, is asking me least count. Least count formula. What is the least count formula? Anyone? What is
One
the least count
MSD
formula?
minus
1
one VSD.
MSD minus 1 VSD. So that is equals to here 1 MSD minus 1 VSD is 9 by 10 MSD. So this is coming out for me how much? Can anyone tell me? 1 is MSD common. 1 minus 9 by 10. Before only we did this one. 0.01 centimeters. Am I clear? What is now? This calculation. It is 1 minus 9 by 10 MSD. MSD value is 1 mm. That means this is a 10 minus 9 divided by 10 into 1 mm. 10 by 10 minus 9 is 1. 1 divided by 10 mm. Okay, that I am converting in centimeters. Okay, am I clear?
Yes.
Because units are being given in centimeters. That is the reason. See here, these are being right now reading 10.3 centimeter, 10.2 centimeters. That is the reason I have taken the least count in the centimeters rather than in your mm. This is 1 by 10 mm. Multiply it with 1 by 10, so it will be 0.01 centimeter. Am I clear? Am I clear?
Yes, sir.
Very good. Chalo. Number B. So what is the second question right now? Can anyone give me the answer? Now the second question is the length of the line is telling that, see, while measuring the length of the line, the zero mark of the Vernier scale lies between 10.2 and 10.3. That means I'll help you out with the diagram. If this is the main scale, beta, if this is the main scale, there is somewhere here reading. This one is right now for me 10.2 centimeter, and here the reading is 10.3 centimeter. Is telling that zero of the Vernier scale, that means down one. This is the zero of the Vernier scale. The blue wala is Vernier scale and black wala is main scale. Better you understand that one. Okay. Now read the question. In the problem is telling that zero mark of the Vernier scale lies between 10.2 and 10.3, and the third division of the Vernier scale is coinciding with the main scale. He has given me the VSR which has been coinciding. Can anyone tell me the reading now? Reading is equals to what is the formula? MSR plus of your VSR multiplied by least count. What is the main scale division? Anyone? What is the main scale division? Zero of Vernier scale से पहले कौन सी reading दिखाई दे रही है? What is the reading which I am able to see before the zero? This is the main scale. This is your Vernier scale. Before the zero of Vernier scale, I am able to see the reading as 10.2. So this one is 10.2 centimeter plus Vernier scale, the division which is been coinciding. Which division is coinciding? He told in the problem. Third division. See here. Third division of Vernier scale is coinciding with your main scale. That means this will be equal to 3 multiplied by least count. Least count is 0.01 centimeters because this one is in centimeters. So this value will come out for me how much? 10.23 centimeters. Because 3 into 0.01 is 0.03. 0.03 plus 10.2. It will be 10.23 centimeters. Am I clear?
Yes,
Am
sir.
I clear? So I hope you got an idea right now how to calculate the least count and how to calculate the readings. Am I clear for everyone? So what is the reading formula? Reading is equals to main scale reading plus of your Vernier scale reading. Clear everyone?
Yes, sir.
Then last topic of this one is about your zero errors. How to calculate the zero errors. Next reading is your zero error. Zero error. Okay. See, if I'm drawing actually the instrument, I don't know where I'm getting it. Got it. This is your Vernier scale, isn't it? This is your Vernier calipers. This backside is been used for measuring the depth of hot liquids. This is the main scale. The down one is your Vernier scale, which is movable. Upper one is used to measure the internal diameters. Lower these two jars are being measured to measure the outer diameters. Vernier scale is movable. Am I clear? This is the basic diagram of your Vernier caliper. Got it? Now see, what do you mean by zero error means you see? See, in between these lower two jars, there is some object it has been kept. When there is no object between the jars of Vernier scale, if the zero of the Vernier scale and is coinciding with the zero of the main scale, that means it has zero error. What do you mean by this one? I'm telling you, see, zero of the main scale is coinciding with the zero of the Vernier scale. Down one is known as Vernier scale, and this one is your main scale division. If both of them are coinciding, then there is no error. This is the first point. Am I clear? Am I clear? When this object is not present, if I remove this object, if I close this one, if the zero of the Vernier scale is coinciding with the zero of the main scale, so what will be the error of that one? Zero error, no error. Am I clear?
Yes, sir.
Point number 2, now very important. Now see here, this is the zero of your main scale. Okay, and this is the zero of your Vernier scale. This one is Vernier scale, and this one is your main scale. Clear? Zero of the Vernier scale. This is the scale right now for me. Okay. So this one is called as of your positive error. Positive zero error. इसका मतलब क्या है? I'll explain you. When zero of main scale, zero of your main scale lies to the left of zero of Vernier scale. Zero of Vernier scale. That is called as of your positive error. Am I clear? When zero of your main scale lies to the left of zero of your Vernier scale. Now to the left of zero of Vernier scale, what is the reading you are able to see, beta? Zero only, na?
Yes.
This one is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, this is 10. It is 1 centimeter. Now see this one carefully. 0 of this one is somewhere here right now. I'll draw this one right now here. This one is here right now. This is a 0 of Vernier scale. Okay. Then if I'm writing the readings right now here, this is the 0 right now for me. This is 1, this is 2, and this one is right now for me 3. The next one is right now for me 4, this one is 5, this one is 6, 7, 8, 9, something like this. Are you able to see the diagram very clearly? Now understand what do you mean by positive error. When 0 of the main scale lies to the left of the 0 of the Vernier scale. Now I need to write the 0 error for this one. So what is the 0 error? 0 error, formula you write 0 error is nothing but reading of Vernier caliper. Reading of your Vernier caliper. Okay, what do you mean by 0 error? 0 error is nothing but reading of Vernier caliper. That means if I write here 0 error is equals to, can anyone tell me, reading of the this one will be equal to how much? Main scale reading plus Vernier scale reading multiplied by your least count. So this will be the zero error formula. Now can anyone tell me what will be the main scale division, main scale reading of the diagram? Anyone? जीरो से पहले मेन स्केल का क्या रीडिंग दिखाई दे रहा है अपने को? जीरो ना, that is zero.
Yes, sir.
Plus,
Sir.
what do you mean by VSR beta? The number which is been coinciding. So this is 1, this is 2, this is 3. 3 is coinciding with the one of the main scale reading. Remaining nothing is been coinciding. So Vernier scale reading means the number which is coinciding. What is coinciding right now for me? 3 multiplied with your least count. Isn't it? Least count in centimeter will be equal to how much beta? 3 into least count is 0.01 centimeter. That will be 0.03 centimeter. Got an idea what do you mean by this zero error? Zero error is nothing but reading of Vernier caliper. Am I clear? Screen is not visible.
Yes, sir.
Okay. Now?
Yes, sir.
Yes, sir. Visible now.
Okay, चलो फिर एक बार देख लीजिए बेटा. What do you mean by positive error? When the zero of the main scale is lying to the left of the zero of the Vernier scale, that is called as what? Positive zero error. Positive zero error matlab left side of the Vernier caliper, whatever the reading you are seeing, that will be the main scale reading. So when the zero of the main scale lies to the left of the zero of Vernier scale, such type of reading is called as right now for me positive error. और zero error निकालने का तरीका, zero error is equals to reading of Vernier caliper. So what is the formula? Zero error is equals to main scale reading plus Vernier scale reading multiplied with least count. What is the main scale reading? Before the zero of Vernier scale, what is the reading of main scale you are able to see? Zero. That is the reason I kept here zero. Now tell me VSR which is been coinciding. See the diagram. This one, 1, 2, 3. The 3 of the Vernier scale is coinciding with some line in the main scale. So VSR will be equal to 3. If least count is not given, least count, basic least count in centimeter is how much for me? 0.01 centimeter. So the answer is 3 into 0.01 centimeter, that is equals to 0.03 centimeter. That will be the answer. Am I clear?
Yes, sir.
Third one and last pick of this one is your negative error. Negative zero error. I'll send the notes for this one better. For the groups, I'll send it to the Safia madam. If you can ask her, or I'll send it to the Sinova sir. They'll give you these notes right now for meeting the students. Okay, na? Negative zero error beta. And I also created separate WhatsApp group. All the interested student, I'll try to add in that one. So directly you can get the notes from that one. Today I'll send all of you individually the notes. So you can check it and try to learn from that one. Now tell me, what do you mean by negative zero error? So write this condition when zero of main scale. Try to understand the terminology. Zero of your main scale lies to the right side of zero of Vernier scale. Zero of your Vernier scale. This is also recording is there beta. I'll upload it on the channel. If you want, you can check it or go for the revision of that one also. Okay. Now see, what do you mean by negative error? Anyone? Negative error means when zero of the main scale lies to the right side of the zero of your Vernier scale. इसका मतलब, I'll draw the diagram here. This is the scale. Okay. And this one is zero of main scale. Okay. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here it is up to 1 centimeter. This one is your main scale reading. What is telling is right now for me, if the zero of the main scale lies to the right of the zero of Vernier caliper, that means down here is right now for me 0. Am I clear? So this one is 0. This one is right now for me 1. This one is 2. This is 3. This is 4. This is 5. This one is 6. This one is 7. This one is 8. This one is 9. This one is 10. Like this. Okay. This one is your Vernier scale. Now read the definition. when 0 of the main scale lies to the right side of the 0 of Vernier scale. That is called as of your zero error. Now, what is the zero error of this one? Anyone? Zero error is nothing but equal to what? Reading. Is nothing but equal to what? Reading. This reading will be equal to how much, beta? MSR plus VSR multiplied by least count. Can anyone tell me what is the main scale reading? Now that is really very challenging for everyone. Someone should give me the answer. What will be the reading of main scale reading? What do you mean by main scale reading, anyone? मेन स्केल रीडिंग मतलब क्या? मैंने स्टार्टिंग में लिखवाया था यहाँ पर आप लोग को. मेन स्केल रीडिंग मतलब रीडिंग ऑफ मेन स्केल टू द लेफ्ट साइड ऑफ जीरो ऑफ वर्नियर स्केल. अब इसमें लेफ्ट साइड ऑफ जीरो ऑफ वर्नियर स्केल में क्या रीडिंग दिखाई दे रही है आपको बताइए? कुछ दिखाई दे रहा है क्या?
नथिंग सर.
नथिंग मतलब जीरो से पहले अपने को क्या रहेगा? नथिंग जब मतलब -1.
-1.
वेरी गुड. इट विल बी -1 बट नॉट 0. am I clear? 0 से पहले क्या रहेगा यहाँ पर? -1 -2 -3 रहेगा ना इंटीजर्स में. तो 0
Yes, sir.
से पहले ऑफ मेन स्केल क्या रीडिंग होनी चाहिए थे? अगर कुछ भी नहीं दिया, नथिंग इज बीन गिवन, that I'll take it as -1 mm plus what is VSR, the number which is been coinciding. I have written in the diagram
6.
very clearly. 6 is been coinciding, so it will be your 6 multiplied by least count in mm. It will be equal to how much for me? 0.1 mm. I have done one question in centimeters. I'm doing one question in mm. So this will be equal to how much for me? -1 mm plus this will be 0.6 mm. So what will be the answer? -1 mm plus 0.6 mm. What will be the answer?
0.4.
Minus 0.4
minus 0.4.
minus 0.4 mm. आई बात समझ में?
Yes, sir.
Am I clear?
Yes, sir.
Yes.
ठीक है ना? तो दिस वाज द बेसिक ऑफ योर वर्नियर कैलिपर. इसको आप लोग थोड़ा अच्छे से रिवाइजन कर लीजिए. कल इस पे और थोड़े अच्छे और स्टैंडर्ड क्वेश्चंस करेंगे. देन विल ट्राई टू डू द स्क्रू गेज. These are the two instruments which I am doing very detailedly, every step by step, only to make that you can do the questions based on this one. Then from the units and dimensions and errors, we'll try to directly go for the revision of the formulas and directly do the what do you call that one, problems to solve the numericals part. In units and dimensions errors, we'll be trying to do 50 to 70 questions, highly expected models of that one, because we'll be getting 2 to 3 questions from units and dimensions. Almost all very huge weightage, even though it appears to be a very small topic. So we have almost all 12 marks weightage for this chapter. Minimum you can take 8 and maximum you can take it as of your 12. If you are perfect with this chapter, 8 marks will never go anywhere. So we'll try to make sure that Vernier caliper, one more small topic has been left out, how to take the readings in terms of degrees and radians. That we'll try to discuss in the tomorrow session of your class. Then we'll try to do the screw gauge, and then we'll try to go for one practice session on this topic of some questions. Then we'll start with units and dimensions. Okay, these are only the orientation classes beta. Properly planned session of your classes I'll try to do in this week. This week I'm just randomly checking my what do you call that, availability of the timings, and in evening how many students will be joining and how much time I can give it. So this week we'll try to just have some general lectures. Then from next Monday we'll try to plan properly what is the first weightage of the topics we'll be doing, so that we can score 80 marks to 100 marks in the final JEE NEET. And along with that one, we'll be doing 30 grand test paper discussions on this topic beta. Overall, 30 grand test papers we'll be trying to start doing on this one, maybe from the moment we completed that 80 marks chapters. Okay, or daily I'll try to take one model paper, and from that one model paper I'll try to do all the problems of units and dimensions, errors, and as well as of your what do you call that one, experimental physics. Okay. Yeah, you can see the recording of this one on my YouTube channel beta. Daily timings will be 6:30, 9:30 only beta. Right now for some timing 9:30 to 10:30. Maybe in nearby future we may increase the time to 11 o'clock also. 9:30 to 11, 1.5 hours or 2 hours depending upon the speed and the ability of understanding. Because literally this lecture has been gone very slow. But after screw gauge, we'll try to do it very faster with the numericals part of relation. My main core area is to concentrate on doing lot number of numerical practice, so that you'll get an habit of doing the numericals from the given topics. Okay. If you have any special request, that we can do it after the 80 marks topics. Okay, and daily section same ID. The class will be at 9:30 for this week. Okay, sure. Take care.
Okay,
Beta.
sir.
Bye.
Okay, sir.
Thank you, sir.
Bye, sir.
Bye.